So as I said before, first and foremost, make sure to go on the GitHub repository and download the zip file for the project. This is just a skeleton project with a few assets inside that we're going to build off of. All right, so who are we? Like I said, we're Concordia Game Development Club. We have over 200 members on our Discord channel, which you could see here. The link, if you can't click it here, obviously for obvious reasons, I put the PowerPoint on the Tech Talk chat channel, so you could click it there. Basically, our goal is to teach and help people learn and how to make games. And this is not only in the programming side, but in art and in music and in game design. Everything that is revolved around making games, we're all interested in here, and we're trying to join people to make awesome games together. We host internal game jams, so every year we do Concordia Makes Games. A game jam basically is a hackathon, but instead of being free to doing anything programming related, it's specifically for games, so you have like maybe 48 hours to make an entire game from scratch. We also did the global game jam that happened in January, where we had almost, I think we had about 250, around 250 participants, and it was like the second biggest game jam in North America, so yeah, we're pretty proud about that. And we also have our own online magazine where we do latest industry news, try to keep ourselves updated, and we also do collaborations with schools like ETS and McGill. So like I said, there's the Discord. We also have a Facebook if you want to see events that are coming up. So what is Unity? Unity is a... sorry, I have to... Okay, never mind. Unity is an engine used... well, it's a real-time development platform or an engine that we use to make games, but it's also used for 2D, 3D, VR, and AR apps. It's also used in other industries apart from games. It's also used in automotive, film industry, animation, architecture, and engineering. Unity is a very fastly growing company. Like it's becoming very, very popular. Not only because it's very, very accessible. Of course, it's free, and it always has the latest updates. So people get new features and abilities while they're using this engine. There's 2 billion copies of Unity games that could be downloaded every month, and there's notably very popular ones such as Ori and Blind Forest, Cuphead, Fall Guys, Overcooked, and many, many more. So today we will be covering the overview of the Unity editor, so the main components that you have to know to navigate appropriately on the engine. We're gonna briefly go through the Unity execution order, the programming in C# on Unity, and we're gonna do a simple 2D platformer. Like I said before, you don't have to download 2020.2.4, the version, but make sure to have a relatively recent version of Unity installed. So yeah, that's about it. There you go. So you could download Unity on this link here. If you click here, you could download Unity Hub here, which I recommend if you want to use Unity in the future, just to organize your files. And you could, on Unity Hub itself, there's an option here. It says add. You could download latest versions. You could take the recommended release. I think it should be fine. Because we're making a 2D platformer, I don't think it would be such a problem if you have like an older version, but you never know. Yeah, download on the GitHub. I already explained this. Download the zip or clone it. And once you've done that, okay, let's see if I download this zip, for example. You go on Unity Hub, which looks like this, and you simply go click on Add. And oh, first of all, don't forget you have to unzip this, so extract it. There you go. So now if I press on Add, you should have access to the workshop. You could select it, and once you did that, it should appear amongst one of your projects. So let me know if you have any problems so far downloading anything, or you don't have any access to the file. If you have any questions, don't feel free to like unmute yourself and ask, because the good thing about doing this presentation on Discord is that you guys could easily talk to me. All right. So once you open a project, you'll have a screen like this, and it's gonna install a bunch of packages and load in your scenes. It might take a while the first time. Maybe I shouldn't have selected this one. I already had the project ready, but I could have opened a one that was already preloaded, but oh well. It's a very small file anyways, so it shouldn't be too long. In the meantime, I guess I could show you guys the Unity, where is it? The execution order. There you go. So this is a very important file. I'm gonna put the link. I mean, where can I get the link? I can't copy the link because it doesn't exist. Oh no. Wait, Unity execution order. Oh, that's not what I was. Execution order. I'm gonna put the link on Discord so you guys could take a look. This is a very useful guide because since everything happens in real time, you want to know the order of when certain functions get called. For example, we will see soon while we're coding, awake is the first function that ever gets called. So when an object gets initialized, this is the first thing that happens. An important one is fixed update. Fixed update is something that happens every frame, but adjusts itself for physics. Specifically, so it's not exactly like every frame per se, it's like a half frame. It's just I mean, not half frame, but it's like it changes depending on the speed of your computer, so to simulate physics nicely. Another main one, for example, there's like a whole bunch here that you could like look at the documentation for sure. But the main one here, update, this one is every frame. So this one is for anything that has to do maybe with inputs, like keyboard inputs, mouse inputs. If you have to move objects within a scene, but not physics related, just translating objects or rescaling them. Everything like that would happen with an update. There's also late the update, which is at the end of a frame. Update is at the beginning of a frame. Late updates at the end of the frame. These are also things that happen, that they loop every frame. And there's other, I mean, there's like on disable when you disable an object, which is the opposite of on enable. I mean, that's kind of self-explanatory. Oh, and then the start here, another very important one. This is to initialize all of your variables at the start of when a game object gets created. All right. So once you're in Unity, this is what you should be able to see. Unity has a couple main windows that we will go through. First of all, there's a hierarchy. The hierarchy is where, actually, before going into the window, if you have a project window here at the bottom, I will invite you guys to go on this scene. There's a folder called scenes. Go on main. All right, here we go. All right, so the hierarchy here is where it basically describes every object that you have in your scene. For example, the main camera, if you click it and press F, it will focus on it. And I have to scroll forward because it's very small. All right, the camera is just the viewport of your game. If you go on this, there should be a panel here with scene and game. If you don't have game, on the top left you have window. This is where you could find any window that you might be missing in your in the editor. So if you don't have game, for example, you could look for general game. So that's this window right here. So yeah, like I was saying, the camera is just what is displaying, what will display in the game when you press play. Right now there's nothing happening in the game, so there's not much to see. But if I were to take the camera and move it with one of these tools at the top left, like that, oh, you see like the scene changed a little bit. All right. So these are where all of your objects will be. Now, the next important window is project. This is where you're going to organize all of your important files, your scripts, your animations, your prefabs. Prefabs means prefabricated object. There's a couple here that I made for you that we're going to fill up. You know, sprites. This is where you organize everything. So you could search for things that you might need. Player. There you go. You got your player objects. There you go. There's a console right next to it. So if you want to debug and find errors, this is where these will show up. On the right here, there's the inspector. So the inspector, if you touch anything in your scene or anything in your project files, there will be some data. Well, there's some important attributes for said object. One of them being transform. Every object in Unity will have a transform. Yes, I am recording. So yeah, every object will have a transform. A transform is basically it has information on the position of your object. It has information on the rotation, and it has information on the scale of your object. So if, let's say, we take this sign, which in the hierarchy, it's under decor, nature, sign. If I were to rotate it, these tools are also very useful for you to know. So move, rotate, scale. This is also a way to resize. Resize your object. So yeah, these tools are for your disposal. All right, so if I were to rotate it, as you can see, the rotation on the z-axis is changing. So you could either change it like this, or you could manually write whatever angle you want directly in the transform. As you can see, it just transformed 90 degrees. And you could also do the same for, you know, scaling and whatnot. Every object have a transform, but not every object have the other components. So this is a sprite, so it has a sprite renderer. Sprite is just an image. But if I go, for example, on player, okay, player also has a sprite renderer, but it also has an animator. So that means it has different components than the previous one. Speaking of which, if you have an object and you need to add extra things, for example, I don't know, it's suggesting a box collider 2D right here. You could write whatever you want, a specific component. You could, let's say you want to add audio to this tree. You just type in audio and there's all of the components that would be associated with that. But if it's collider, for example, and I add this, there's a green box that appeared around here that you could mess around with and resize. And I'm not going to go too much into the details of box collider for this tree because that's kind of useless, but I will for a second for the player. Another important window apart from the inspector is if you go on window, actually no, it's not in window, it's in edit, project settings at the bottom here. This is also a pretty important window because this is going to be all of the, this will handle anything that has to do with how the graphics, the inputs, anything that has to do with like the behavior of your game, that you don't script per se is going to be related to project settings. So one of the main ones that you might be messing around with quite often in project settings is input manager. Input manager just describes the keys and buttons that you would have to click to do certain actions. There's a whole bunch of ones that are made for you already, but if you want to do your own, you want to create your own, you could add new ones and call it whatever you want. And yeah, so I mean, for this project per se, we're not gonna do that, but yeah, project settings are useful for things like that. All right, so I think that's pretty much an overview of the main components of the editor. If you have any questions, if you're missing any windows or anything, just let me know and I'm gonna help you find it. There's also a couple of like in the scene editor, the scene window, there's a couple of like attributes at the top that you can mess around with. For example, if you want to do a 3D game, for example, there's a 2D button here and you just click that and all of a sudden you enter a 3D game. So I don't know, if for example you started a 2D game and decided, oh well, I want to do a 3D game, and now you could just toggle that on and off. Anyways, and there's also gizmos. This could be useful if you're debugging. Gizmos are just things that appear on the screen, but won't appear in the full game. So it's only while you're in the editor that these things will appear. I mean, there's there's a million of them. I'm not gonna go through all of them, but let's say for the camera, if you want to get rid of that huge icon, you could probably find it somewhere in here and toggle it off. Camera. There you go. Oh, okay. Well, it kind of did it. It did the outline, but not the camera itself. But yeah, that's about it. Yeah, so yeah, project settings is an edit, and that's at the bottom, project settings here. Okay, so that's it. Next, what shall we do? What was in the... let me kind of remind myself what I was going to do. Programming in C#. All right. I think now it's time to start programming. The first thing that we were going to do is we're going to do a simple script for character movement. So if you go in prefabs in the folder here, you have player prefab. I'm going to ask you guys to just drag that character and add him to the scene. So we have a little elf here. The first thing that you want to do is you want to, well, we're going to have to create a script. So in the script folder, I'm going to do right click and then create, and then C# script is going to appear here. So I'm just going to call this player controller. All right. So once you create the script, you want to take your character and drag and drop this script onto the object, on the inspector. Another way for you to do it is, like I said, you could do add component and then player controller. The script is going to just appear here. So there's 2 ways of doing it. And then once you do this, before doing anything crazy, this is a very important step. You have to go on edit and preferences, is it? Yeah, preferences. If you go on external tools, make sure to have Visual Studio here as your external script editor. If you don't have Visual Studio, you could use any other script editor that you want. But the recommended is Visual Studio because Visual Studio has like an built-in function. I mean, it's set up. It has a built-in setup in its when you install the IDE. It has like built-in settings for Unity specifically, so it just makes things easier. But yeah, make sure that Visual Studio is here. I forgot to talk about that, but hopefully that doesn't cause too many problems. All right, so once you have that, you right-click on Player Controller Script and go on Edit Script, and this should open up Visual Studio for you. All right, so once you enter Visual Studio, you'll notice there's already a few functions and things are set up for you. This is, I think, what I was talking about, how Visual Studio has like already built-in settings for Unity specifically. So I don't think if you had another editor it would do this automatically. I have never tested, but yeah. So there's a couple packages that come from the Unity engine. So for example, the monobehavior class comes from the Unity engine library. And basically, monobehavior, if you press F12 on it, is it's the parent class that will define all of the, like we went before, the execution order. All of these functions that I talked to you about before all come from monobehavior. So this is where all of the real-time logic and functions come from. It's the parent object class, I mean. So let me just go back. We don't want to go on this. All right. So we have player that is a child of mono behavior, and it's overriding functions start and update automatically. I mean, that's okay. We could leave that there. The first thing that we want for movement, we want a speed. Whoop. Give me a second. All right, so the first thing that we want for movement is we want to define speed. So the first thing one of very useful things that is going to be very prominent in many of your Unity code is something called Serialized Field. So if you start writing serialize, it should like autocomplete for you. It's called Serialized Field. This basically just gives you access from the editor to modify and set your variables in the script. So we want to make a private float m speed. And forgive my typos here. Why do I write m speed? That's just Unity convention. I'm just going to show you what happens. Because of this serialized field, it should show up in the editor itself. Sometimes it has to recompile, so give it a sec. Hello, come on game, you can do it. All right, so as you can see, speed, now we have access to that variable and we could set it up. We could, I don't remember which speed I put it when I was making this project. So let's say we'll put 3 for now. You notice that the M like disappeared. Like I said, that's just a convention. This is just convention for Unity. M just stands for member because it's a member variable. All right, what else do we need for a character movement? We need the we're gonna make a variable called vector2 input vector. This variable is just gonna be basically telling us if we're moving right or left. It's vector2 is the x and y coordinate. It's just gonna tell us, oh, how much are we moving in x and how much are we moving in y. So that's about it for the variables that we want for the movement. So actually, one last variable that we want is a Boolean that will tell us if we're moving. Okay. So in the start method, this is where we initialize any variables. So is moving. We're going to initialize it to false. And the input vector is going to be equal new vector2. And it's just going to be an empty vector of zeros. Okay. Now, we have to make a new function called movement. Oop. This is where we're going to handle all of the logic for movement, which is pretty simple. Actually, before I do that, we have to do a function for handle input. So this function handle input is going to handle all of the button presses that we're going to do, and movement is the logic for actually moving our character. So handle input, we are going to be using WASD. Thankfully, there's already a built-in input handler in the project settings for horizontal and vertical inputs. Here it's called horizontal, and if you look down, you'll see that the negative button and the positive button is left and right, or A and D, so we're just going to use that to make our lives easier. So to do this, we make a new variable. Horizontal is equal to input. Input is the class, well, the object that has access to all of the different types of input that you want to use. But now we have to use the function getAccessRaw horizontal. Okay, and you might be wondering what is a getAccessRaw? GetAccessRaw means basically if you're pressing horizontal, it's either going to be 0, 1, or -1. It won't be anything in between. If you were to use getAccess without the raw part, it will be like from -1 to 1, so it could be maybe like 0.6, or you know, it could be in between numbers, but we don't want that for a 2D platformer. And our moving boolean will just be equal to horizontal if it's not equal to 0. So if there's any movement whatsoever, then if there's any input whatsoever, then we're moving. That's all this means. All right, and now we want to do the input vector. We want it to be equal to whatever the horizontal gives us. Horizontal. Since we're just moving left and right, we don't care about y-axis. So it's just going to be horizontal and then 0. All right, now in movement, there's a couple ways that you could do character movement, but the simplest way is to use transform dot translate. This is a function that gives you, this function tells you to take an initial position and move it, take that initial movement and like move an object to a new position. So the first variable is the initial position, and the second variable is the new position. So the initial position is, actually, is that how it is? Move the transform in the direction. Okay, never mind. That I got confused with another function, but it kind of does the same thing. It just translates, it moves the object towards a certain vector, and that vector is going to be input vector. And, I got confused with another function called smooth damp, which I might go talk about later, but that depends on the time. All right, so first, yeah, so we put the vector that we want to translate towards, and we also want to use the speed. If we don't apply the speed, we might be moving very, very slowly, so we just multiply the vector by the speed. And we also have to multiply it by time.delta-time. This basically is a way of telling the game to move, to adjust the numbers that of this multiplication depending on the speed, the frame rate. So because let's say you have like a very quick computer, the numbers that will appear here will adjust to the very fast frame rate of your computer. But if you had like a very slow computer, I mean, it will have different behaviors if you like you don't do this adjustment here. So that's it. All right, so that's it for movement. The last thing that we have to do is that we want to put these functions into the update so that it loops over them every frame. So this is what you should have now. If we go back to the game, there's one last thing that we have to do. We have to add 2 components to our character. So if we just leave our game like as so and press, excuse me, if we press play, so our character moves very quickly, so I might have to adjust the speed. But you might notice that he's floating. We don't really want that. So we have to add a rigid body component. Rigid body components is basically what simulates physics in game. So as you can see, you have like a gravity scale. If you increase this, so the gravity is going to be very, very high. We want it dynamic so that it simulates it in real time. Kinematic is more so that, well, it's kind of hard to explain, but kinematic is more, you have to kind of describe the game through code how you want the gravity and physics to behave, but kinematic takes into account colliders, which I'm gonna get into a second, It's going to detect if there's collision between objects, but it's not going to simulate like collision, like how do you say, like knockback or gravity and a whole bunch of like physics things like that. Those are a little bit more complicated. Anyways, so yeah, we want to simulate gravity so our character falls, and we don't want it to float. But if I press play, you'll notice, oh, he just like fell through the ground. I mean, it's kind of hard to see, but we don't want that. We want the character to hit the ground, so we have to add another component called a collider. So if you type collider, you should have box collider 2D. And let's see, if you press the edit collider button here, there's a green box, so we just could adjust the size of the box to fit our character a little bit better. Something like this should be okay. All right. So the collider, what it does is just basically telling the game to prevent the character from going through objects. If there's two colliders that touch each other, they won't go through each other. Unless, that is, you press is trigger, which is something that you might want to do eventually. This is just, instead of you wanting two things to stop from touching each other, is trigger is going to let that happen, but you might want to have like behavior detecting, oh, what happens while one object is within another. Kind of vague, but we might have time to get into it a little bit, because when we're making arrows. Anyways, so now that we have collider and a rigid body, if we press play, as you can see, our character now touches the ground and is moving. But you might notice that he's only facing one direction. So I think the next thing that we could do now is code the face direction to adjust the which direction our character is facing. I'm repeating myself, I noticed, but yeah. All right. Let me just check if there's any questions right now. Everything seems good. All right. So what do we want for the face direction? We want to make a new vector component. I'm gonna put it right here. Private vector2, and I'm gonna call it direction vector. This is gonna be a vector that's gonna describe if we're looking right or left. All right, so I'm going to update the vector that we just created in the input manager. So if we are moving, we want the direction vector to be equal to horizontal. All right. Also, we want to initialize the direction vector. So we're going to put it here. Direction vector is equal to new vector to transform. Okay, so now there's a couple of like variables that you have access to in scripts, because this is part of the object. This is a child component of the main object, the one here. So the script is a child component of this entire object in the inspector. So we have access to this variable for the transform. So things like that make things a lot easier. So transform is just like the positions. Our initial direction vector, we want it to be the why did I put position when I wrote this? I'm gonna put scale. We want it to be the initial local scale. in X. Y is the local scale. Basically, the logic that I'm doing right now is that the initial direction that we're going to have is the initial scale in X that we currently have. But if we're moving in the left direction, we want the X scale to be -1. You just see that the character just face the different direction. So we just want to adjust the number here. But initially it's going to be the one that we currently have. So just write vector 2 transform local scale in X. And in Y, in Y we want, we probably want it to be the local scale as well. In Y, whoops, like that. If we put it as 0, we won't be able to see our character anymore. All right. Now we also want to write a new function. We're gonna call it face direction. So if we are moving, we want to readjust the local scale of our character. So we have to make a new vector 2. Oh, I'm sorry. The direction vector I just noticed is gonna be used for something else. Just leave it there for now. But I just noticed that for the face direction, we're just gonna be using our input vector. My bad. So in X times. Oh, okay. Now I just remembered the variable that we actually did want is something called the initial scale, not the direction vector. I'm just gonna comment out the direction vector for now because it's not something we're gonna be using. But we have to make a new variable for the initial scale. All right, so we initialize the initial scale here. Whoop. Like that. And the initial scale is just going to be transform dot local scale. All right. My bad. I hope this doesn't confuse anyone too much. I just went ahead of myself. This also I'm just going to comment out for now because we're not going to use it. Okay, so back to the face direction function. We have input vector dot x times the initial scale dot x. Why am I doing initial scale? This is just in case that right now we're lucky that our character, the scale is 111, but if in the future you decided, oh, I want my character to be, I don't know, a bit larger, who knows, a bit chubbier like this, we want it to be able to update automatically, so you have to multiply it here. So that's for the x, and for the y we want to do the we don't want to change anything, so we're just gonna take the current scale for the y, like that. Okay, so what's happening here? We're making a new vector. So input vector is as I said, it's either -1, 0, or 1. So this input vector is going to be either -1 or 1. Y, that's because is moving. It's never going to be 0 because this line of code is only going to happen while the input vector, yeah. Does this make any sense? The input vector is only -1 or 1 when it's moving. There you go. And it's never 0. because of this boolean that we're checking right here. So, all right, so this should do the job. Let's just take this function, copy it, and put it into the update. And if we go press play, and sometimes it takes a while because it has to compile. Okay, there you go. So as you can see, our character is moving left and right. That's what we want. All right, so the next thing that we want to do is we want to jump. So similarly to the speed, we have to make, I just did Control D here to copy. We have to define a jump force. So this, if we go back into the editor on the player, you should have a new variable that you could modify here, a jump force. So I'm gonna put 2.5. This is something we could adjust later if 2.5 is too strong or not strong enough. Okay, so for the jump, we have to add an input here. Okay, so we're gonna add a button that will tell the character to jump. So a good one that usually 2D platformers use is the space button. So just do if input dot get button down. Okay, now here I'm just gonna put jump. And you're wondering, why didn't I put space button? That's because I don't remember what is the shortcut for the space button. So I'm gonna define it myself. And this is where the project settings I explained before comes in. So in project settings, input manager, we want to create a new input. So just in the size variable here, just add 1. And we want to define a new jump. And jump is going to be space, the space bar. So, and the positive button variable here, just put space, and that should do it. Okay. And just let me know if you missed anything. Let me just check the... Okay, is everything okay? I see there's some questions on the chat. Can you tell me where to access it later? I see someone.
She means probably the, like, because we're recording it.
Yeah, we're recording it. Mm-hmm.
So, because then they might want to see it later.
Okay, all right. All right, where was I? Okay, so now we defined jump. Now we want to make a new, we're gonna make a new boolean that is jumping. And we're gonna go in the start method and say is jumping is false at the start. Okay, but now if we press spacebar, is jumping is going to be equal to true. Oop, like that. All right, so we're going to handle the jumping behavior in the movement function. So in movement, we're going to have if is jumping. Now, what we're going to do is we're going to use the physics functions of the game to add a force to the object to push it upwards and simulate a jumping behavior. So to do this, like I said, the component that simulated physics was the rigid body. So we have to first of all get access to this rigid body component. To do this, we write a new variable called rigid body 2D, since we're working in 2D game, If you're working in a 3D game, it will just simply be rigid body without the 2D part. Sometimes this could cause a problem when you're doing a 2D game, because some functions require you to write the 2D or else it won't work. So be careful with that. And we're going to call it rigid body like that. In the start method, where we're going to initialize it, we're simply going to do m rigid body is equal to okay, so this is a very, very useful function that is like really used very often. It's called getComponent. If you have an object and you have maybe a specific component with it that you want to add behavior to from the inspector, like for example, so the rigid body, for example, is one, box collider 2D is one, animator. All of these are components that you want to have access to. To get access to these components and to add behavior to them, you do get component and then just write down the name of said component like that. All right. So this is used very often because games require you to like, get access to many of these components quite often. So good thing to keep in mind. All right, so once we have our rigid body, we're just gonna add a force to it when we jump. So we have to do m rigid body dot add force. We're gonna make a new vector that's gonna be just a upwards vertical vector. So it's gonna be 0 in the x and jump force in the y. Like that. And then this variable, this function is telling me, oh, there's two, I have to put two parameters. The next parameter is what type of force that we want. We want a impulse force. This is up to you. Like, there's many different types of forces that you could choose from, but we want one that's instantaneous and happens only once, so that's why we use impulse. You can look at the Unity documentation for many different types of forces that you could look at. A good thing about Unity is that documentation is like really, really good, so if you have any questions for that, it's like good resources online. And once we jump, we want to reset the is jumping back to false. Like that. All right. This is simply to prevent you from jumping multiple times. But actually, this is not completely done. There's actually another component that we have to check. We want, like, as you can see, I'm just going to go back to our game. So if we press space, now we could jump, so that's good. But the problem is if you press space multiple times, oh, we're flying. This is not very good. So, oh, I just noticed something. Our character almost fell. It was like rotating. There you go. We don't want that. So, you could add constraints in the rigid body to freeze the rotation. So in rigid body, constraints, freeze rotation, just checkmark the Z axis. And I think that should solve the problem. Yeah, all right. Okay, so yeah, we don't want the double jumps, unless that's like how you want your game to work. But we only want to jump when the character is grounded, is touching the ground. So this is where we have to add a ground checking logic. So to do that, we are going to use the layers of the layer attributes of the game. Layers basically define, especially in 2D games, different parts, different objects. There's like a tag, there's tags here that define, you could select an object and tag it whatever you want. If, for example, you want a certain object to have its own behavior controlled by the tag that it has. But there's also the layer, which is quite similar, but layer allows you to use... It's a little bit more flexible because you could use raycasting or check overlaps of colliders. It's a little bit more kind of elaborate than the tag system. So that's why we're going to use this for the ground checking, because the layer component is going to check whether or not our character is overlapping to the ground. So to do that, we have to, first of all, if you go on the character, actually, if you go on our player and you right click on him, we want to create an empty component, and we're going to call it ground check. If you go on ground check component, we want to position it where the character's feet would be. That's where you would assume the character's touching the ground. And we want to add the ground. Okay, so if you don't have this layer, the ground layer on your... Actually, am I doing this right? Okay, I don't think the layer here matters. Actually, what we want to define as ground is the grid. So if you go on grid, yeah, the tile map should already be defined as ground for the layer. So if our character, if this component, we're going to add a script to this component, which is going to check whether or not it's overlapping with the ground. So it's going to tell us whether or not we're grounded or not. So we're going to do that right away. We're going to go back to scripts. We're going to add a new C# script, and we're going to call it ground check. Okay. And we're just going to open that up. Okay. Let me just check the chat if I'm going too fast or something. All right, seems okay.
No, all good.
All right, cool. All right, so the script, we don't need any of these functions. We're just gonna give a Boolean. It's just gonna be a function that's gonna give us a Boolean whether or not we're overlapping with the ground. So we're gonna make that function, check collision. The first component is gonna be a radius. So this is gonna define how much we want to allow the overlap to happen. We want to have a variable for the layer that I was talking about earlier, which was defined as ground. So what is ground? And we want game object ignore object. So this is just going to be defining what is the object that we're doing this ground check with, which is going to be the player. But we're going to go back to that in a sec. All right, so in this function, we have to do collider 2D. Colliders. It's going to be we're just going to return everything that this ground checker, I guess, object is colliding with. So to do that, to return the array of potentially many things that the object is colliding with, we use physics 2D dot overlap. I mean, there's many different overlap functions that we could use. Let's use circle. I mean, I don't think it really matters, but transform that position. Okay, and radius and what is ground. So these are just the parameters that overlap circles asking for. If you hover over the function, or actually if you go on the Unity documentation, overlap circle all, there you go. And it says, there you go. It describes like what the parameters are for. So the first parameter is the center of the circle. The second one is the radius of the circle. And the third one is the specific layer that you're checking with. So that's just what we did right there. Okay, and now that we have all of the colliders, whoop, what is going on? Okay, we want to go through them, iterate through them. Collider to be collider in colliders. If the collider dot game object, this is just defining if the collider object is not the player, ignore object is going to be our player. We don't want to check this collision if the collision is doing it with itself, so that's why we're ignoring it. Or object. Then return true. And if not, then just return false. Why is, oh, I forgot an S here. Okay, so yeah, so this is what this is doing, this function. It's looking for everything that the circle is colliding with, depending on the layer. And for each of those, check if it's not the object that we're trying to ignore, which is the player. If it's not, then return, yes, we're doing a collision with the ground. Else, we're not doing a collision with the ground. That's what this is doing. Okay, so we get back in here. And we add the script to the object that we added here, the feet. And now all we have to do is go on the player controller function class. And we're gonna do a new function called check grounded. Check if grounded. Okay. And if, now we're gonna use the function that we just created. So actually, before going into that, we're going to create a new serialized field. This one is going to be for the feet that are checking the ground. So we're going to call it m ground check. Okay. And m ground check. Actually, before doing that, I'm just going to explain what I just created here, the serialized field. If we go back into the player function and player object here, we could just drag and drop the object that we created here. So I just took the feet ground object and dragged it onto the player. Okay, so now it's there. We don't have to initialize it because I defined it like that. All right, so if check and grounded, now we're gonna use the function that we just created. Give me a second. All right, so using the object that we just created, ground check collision. Is that what I called it? Check collision? Oh, wait. Oh, my bad. I did a mistake. In the serialized field, we don't want a game object. We want to call this ground check. All right, because that's the class that we created here. So now that should give us access to the function inside. And inside we're gonna do, so the first variable was the radius. We're gonna make something really small, 0.01. And then the layer mask, we're gonna do, I think I have to use string. Actually, I'm gonna create a variable that is gonna define the layer that we want to check. We're gonna call it layer mask m what is ground. Okay, so this is just gonna define what we want to collide with, and so the second component is gonna be m what is ground, like that. And the third component was the object that we want to ignore. So like I said before, we want to ignore ourselves. We don't want to do any collisions with ourselves. So just simply write game object. That's the player object. Oh, here there's an error for 0.01. That's because we have to add an f here to define it as a float. All right, now, so do the ground check. If it returns true, that means we're grounded. So, oh, I forgot a parentheses here. All right. Oop. Yep, I'm getting a bunch of errors. No, I'm just clicking a bunch of random buttons by accident. All right, so if this function returns us true, that means we're grounded. So the variable, the boolean that we had defined before, is grounded. Oh wait, did I not do boolean? Okay, there's another variable that we have to add here. Private bool is grounded. All right, we're gonna initialize this boolean as false. Actually, we're gonna initialize it as true because at the beginning of the game you should be on the ground. So like that. Okay. Now is grounded is equal to true, else is grounded is equal to false. Okay, there you go. So all of this is so that we don't jump in the air. Now for the movement is jumping, we simply do is grounded and is jumping. So we only jump when we're touching the ground. That was quite complicated, but it's actually a very important part of 2D platformer, because 2D platformer often requires you to check whether or not you're touching the ground, or if you're hitting the ceiling or crouching. There's many functionalities, so it's a good thing to learn how to do. And also, obviously, you don't want to double jump, so there's many reasons why you want to do this. Okay, so if we go back to the game, there's one thing that we have to do before we press play. The ground check, it's uninitialized. Let's just drag and drop that there. And what is ground? We want it to be defined as ground. So there we go. Now, if we press play, we shouldn't be able to double jump anymore. Oh, wait. Okay, so we're still double jumping for some reason. Did I do something wrong? Give me a sec. Grounded true. Check collision. What did I do wrong here? Interesting. I don't know why this is not working. I'm gonna try to fix it later. I'm gonna move on for now. It's not like a huge priority. So the next thing that we want to do, we want to, let's see, I guess we could start doing shooting arrows. So we want our character to shoot projectiles, but to do that, the first thing that we want is access to said projectile. So we're going to add a serialized field again, and we're going to do game object. This is game object is like the most general class that you could use when gaining access to like a different component in your project. The reason why I'm doing game object is because we're gonna be adding a prefab which has a whole bunch of behavior of its own, so we can't go too specific and use like a specific class like ground checked. We have to use like the entire object instead, because this game object will have like its own components. But yeah, so we're gonna call this game object M projectile. And all right, so let's see. We're gonna have an input that will tell the game to shoot said projectile. Okay, so first of all, we're gonna add, I think we should write a new input. So if input dot get button down, I'm gonna use one that's already in the project settings. It's called Fire3. Just as shift button. Okay. Now, I'm going to introduce you guys to something called a coroutine. Coroutine basically is a way of starting a new thread, which will, it's useful if you want to like do a countdown, if you want to delay something while the game is still running, because, for an example of the projectile, it's kind of not obvious right now, but I want to add a shooting animation, but the shooting animation lasts a fraction of a second. If we were to shoot the projectile instantaneously, it won't be in line with the animation itself. So the coroutine basically is just a way to start a new thread if you want to do a countdown while, yeah, it's just a code that will execute at the same time as everything else. So in this case, it will just be for doing a countdown. So before starting the coroutine, I'm going to define it. I'm going to add it here. We're going to call it shoot. So first of all, the return variable for a coroutine is iEnumerator, and we're going to call it shoot, like that. Okay, and what is going to happen inside shoot? First of all, let's create a new boolean for shooting. I know, there's like, for every action, there's a boolean. This is some very typical of coding in Unity. So is shooting will be equal to true. And the coroutine, we want it to have a delay, like I said, so that it matches the animation that we'll do right afterwards. So to do the countdown, you write yield return mu, and then we use the function wait 4 seconds. And the animation, if you go, I mean, I'm not gonna go with it, but because I calculated how much time it did before, but it around 0.3 seconds. That's when the projectile should shoot so that it matches the animation. All right, so basically what's going on, once this coroutine is executed, the first thing that happens is that shooting becomes true, and then it's gonna wait, it's gonna do the thread, it's gonna loop through this thread, this function for 0.3 seconds, and once it finishes that 0.3 seconds, then it's gonna skip to the next part of the function where there's gonna have more code, which I'm going to do in a sec. So to start the coroutine, you use a function called start coroutine, and inside you just write the name of the function that you want to start. So shoot, like that. All right, now we're going to add the behavior for the shooting the arrow. To do this, we're gonna go on the arrow prefab. So in assets, prefabs, arrow. There you go. This has no script attached to it yet, so we're gonna just make a new one. So we're just gonna call this projectile. And we're gonna attach the script to the arrow, like that. Just drag and drop. And we're gonna edit it. Okay, so let's see. Okay, so the behavior for the projectile, the first thing that we want is we want to define the speed. So we make a new serialized field. This is exactly like what we did for the player controller. And speed. Okay, and we're gonna do an impulse force when we shoot. We're just gonna do an initial force at the beginning when we press the button. So to do that, like we know, we get the rigid body 2D. Rigid body. I just noticed that the arrow itself does not have a rigid body, so I'm going to add it. Rigid body. There you go. We're gonna remove the gravity because we just want the arrow to apply a force in one direction. We don't want it to fall, so that's why we're doing it like that. Alright, so I'm just looking at the chat real quick. Wouldn't it be easier to do it after the end of a frame instead of seconds? Well, the end of a frame would happen like a lot quicker than a set number of seconds. Like a frame like lasts is it's very quick. You know, it's 0.0001 seconds. We want it to be a little bit longer than that, so that's why I have to define the coroutine number of seconds. Alright, so let's see, where were we? Okay, we're gonna add a new function to, well, first and foremost, we want to get the component, rigid body component. I actually forgot to do this in the previous code, but everything physics related, we want to do it in awake and in fixed update. So instead of initializing rigid body in start, we're going to do it in awake. This is a new function like that. All right, so rigid body, is equal to get component rigid body 2D, 2D, like that. And we're gonna make a new function here called shoot. And we're gonna take a vector 2, which is gonna be the direction that we're shooting in. We're going to define the direction, like the facing direction of the arrow. So depending on if we're looking right or left, we're gonna rescale the arrow. So this is very similar to what we did in the player controller, just if the vector is going to the right, it's going to be 1, and if it's going to the left, it's going to be -1. So transform dot local scale dot x. Okay, this might be confusing, but the reason why I'm keeping the x coordinate as so, and I'm actually going to readjust the y coordinate, is because for some reason the prefab object is facing upwards. The object, it doesn't look like it, but while I was testing this, this arrow head is like, if you initialize it, it will actually be facing like this. And we don't want that. As you can see, like the Z, I had to redefine it as -90 to do this adjustment. So that's why because of the -90 degrees part, instead of readjusting the x coordinate so that it faces left or right, we have to readjust the y coordinate. It's kind of weird, but trust me on this. Basically, the vector that we're taking here, if it's facing to the right, we want to change the y coordinate to the opposite of what it is, and if it's facing the left, then it's opposite of what it is currently. Yeah. Just trust me on this. It's just because of the weird orientation of the arrow, but it's a necessity. All right, so now we also want to add a force in the direction that we're facing. So add force times the speed, and we want to do the impulse mode. Impulse, like that. All right, so that's it. That's all we have to do for that. And back to player controller. Once we shoot and we go to the shoot coroutine, we just we have to instantiate. Instantiate means create a new object. We're like we're initializing a new object, projectile. This is gonna spawn into the scene when we press the fire button. Instantiate. Instantiate is the main method if you want to spawn new objects, basically. So we take the prefab object and projectile. Actually, instantiate, there's many ways that you could define it. The first variable is the object that we want to spawn. So M projectile, that is. The second one is the position. The third parameter is the rotation. You see +10 overloads. There's like 10 different ways that you could define the parameters. We're just gonna do the position rotation one. So the transform, the position is gonna be our current position. So just like that. And the rotation is just gonna be the projectile's initial rotation that we defined in the prefab, so like that. Okay, as game object. All right, so yeah, we create a new projectile, we spawn a new projectile, and then we want to use this shooting method that we created here. We want to add a force to it. So you just do projectile dot get component projectile. That's the script that we attached to it, and then we do shoot. Why is it not working? Shoot. Okay, what's going on here? Projectile. Oh, here, make sure to make the function public so that we get access to it. Is that not the reason? Hello? Okay, now it's asking me to put a parameter inside, so okay, so that's the direction, the direction vector that I had before that I made you comment out. Now we're gonna use it. So uncomment direction vector. Direction vector is gonna be, yeah, like that, and uncomment that. Let me just check real quick if I missed anything. I think that's, yeah, I think that's okay. Let's just put the direction vector inside. Okay. All right, so now that everything is done for the script, let me just check if we're missing anything. Okay, so the speed of the projectile, we have to define it. I'll put 2. And, all right, let's see if that works. Actually, it won't work because we have to, here you see projectile, the game object is still empty, so we have to take the arrow prefab and drag and drop it into the slot there. So now if we press play and we press shift, we have arrows. Woo! Our jumping still doesn't work for some reason, but I don't know. Oh, I don't know why it's reacting like that, but we have projectiles, so that's the important thing here. Okay, let me just check. All right.
Do we have time for more?
I don't know. I was gonna do like I could do the animation. I don't think I'm gonna have time for the mole, unfortunately.
No.
Oh well. But I'll do the animation and the basic 2 animations, and I think that would be, and maybe fix the ground check if I have time. So the next thing that we're gonna do is the animation, because I was just going on about like, oh, why am I doing the coroutine for the shooting? That's because I added an animation for that. So if you go on the character and okay, so there's missing a window here. I would suggest you guys to go on window, go on animation, and animator. Okay, there's a new window that's just open. Just drag and drop that there. And I'm also going to add one for animation, like that. So I'm just gonna put these 2 next to each other. All right, so here on animation, there should be a couple of options. There's walk, there's shoot, and there's idle. I just wanted to show the shooting one. As you can see, it takes like about 0.26 seconds to do it. So actually, back into the wait for seconds, I'm gonna adjust that to 0.26 to match the length of our animation. Okay, so yeah, the reason we just wanted to shoot when this animation is complete. So let's do that and plug in the animation so it looks nice and slick. All right, so let's see. Okay, so the first thing for the animation is very similar to the rigid body. We have to gain access to the component. So we have to do private animator and we'll call it animator. Let me just adjust this real quick. I put the rigid body in the start method when it should be in the awake method. So I'm just gonna add a new awake here. That's where it should be. That's where it belongs. All right, so now the animator, we have to initialize it. We're gonna put it in the start method because it has nothing to do with physics. And I did a little typo, so animator, there you go. Animator equals get component animator, like that. Okay, now we want to only do this animation when it's shooting. Okay, so this is why I had so many booleans, is mostly because not only to, you know, check if it's grounded or if it's moving, but also these are very useful if you want to program the animations. So to do the programming of the animations, I usually make a new function just for it. So I'm just going to call it animations. Animotions. All right, there you go. And here I just basically, if you go on the Unity editor, I already made these animations for you. So if you go on animator on the player, you see there's like a kind of a there's like a flow of different transitions between states. It's a state machine for specifically for animations. So between shoot and idle, there's like a transition. Walking and idle, there's 2 transitions, and so on and so forth. Basically, what we want to do, if you look at the parameters here, there's like a little window here. There's 2 parameters that define the logic between these transitions. So if, for example, we go from idle to walking, you'll see is walking is equal to true. And if you select the other arrow going the other way, is walking is equal to false. So we use these parameters basically to define in the game when an animation is going to occur. This is just simply going to be animation, the animator object dot set boolean. And this is going to take the name of the parameter. These are going to be exactly the same. They need to be exactly the same as they're defined in the editor. So no typos. If there's a typo, it won't work. So we want to do the is shooting one. So here is shooting like that. We want to set it to whatever the value of is shooting is, which is the boolean that I defined, is shooting. Okay, and that's about it. We take this animation function and we put it in the update method like that. Speaking of which, earlier I explained how the rigid body deals with physics, and we're using physics in the movement method, so I think it would be more appropriate to move this function in the fixed update instead of update. Fixed update is, like I said, it's better for handling physics, so I'm just going to add it here, fixed update. And I'm going to take this movement function and paste it right there, because that's where it belongs. Very similar to the awake here. All right, so I put the animations function in there. So let me just check if the shooting logic is well set up. So once it's shooting, it's true. And we want it to be set back to false afterwards. So we're gonna do it after it finished animating. So once it animates, is shooting is gonna go back to false. All right. So now, if we go back here and press play. Okay, so there was a collision somewhere. I don't know what happened. You saw the arrow go like upwards, but the animation for the arrow seems to work perfectly. So that's why we did the whole coroutine thing. All right, and now we could do the animation for walking as well. It's very similar. So animator dot set bool, and then we just do is walking, and we do the moving boolean is moving, and let's see if that works. Okay, it does, but our character's a little quick. So I'm just gonna reduce the speed here. Let's put the speed to 1. Okay. There you go. So now our character is moving around and shooting. It's very cute. Alright, let's see if we could, before ending, let's see if we could fix the is grounded method. I don't know why it's not behaving like it should. Alright, check if grounded. Is it because I didn't put it in the update? Yes, it is. So it's very, very easy fix here. I just forgot to put the function in update, check if grounded. So don't forget to do that as well. Okay, so now if we press play. Okay. There you go. Now we can't fly anymore. So everything works perfectly. Ta-da! All right, let me just check. Do you think, George, do you think we should end it now? Or does anyone have like any questions? I don't think I have time, unfortunately, to
No, we don't have time to put the
program
enemy,
the moles, the enemy, but I'm going to post the full project on the GitHub. I'm going to, you could like re-download it, and like after the stream, if you want to see like the full code. And
Yeah, sure. Also, people said they want their recording.
Yeah,
Like some
I'll
people who had
put
to
the
leave for
recording.
classes. Yeah, they said they want their recording, if possible.
Yeah, I will definitely do a recording. That's no problem.
All right.
Thank you for joining. Do you guys have any questions? Things that you would want me to cover, or that maybe
I try to answer as much as possible in the chat.
Yeah,
Whoever
that's
had
good,
questions.
that's good.
But overall, like we had a good peak of people who joined. Like a total of 30 people like came in when left. So, but that's pretty normal when it's a workshop, like a tech talk here.
Yeah. All right. Thank you very much, guys, for joining. I hope you learned, and I hope you enjoyed the tutorial. I know
some of them
there's,
already joined the group.
I know it's
already.
a lot. It's like pretty heavy, and that's why we wanted to focus a little bit more on the programming side as opposed to the other components like animation and UI and stuff. So I hope that wasn't like too overwhelming. We just wanted to cover maybe what would be more interesting for programmers in the channel. So yeah, I hope you learned from it, and I hope that this will push you potentially to make games of your own. And
yeah, they already joined our Discord server.
And you could, if you join the Discord, if you have any questions, we're there to help. We're gonna do many more workshops, or at least gonna try as time allows us. But we're also gonna be doing game jams, which is another good time to like learn new things, which is really fun because you're getting to meet new people and to experiment with new tools, and it's just a fun time usually. All right. Yep. So thank you again for joining. I hope you have a wonderful night and a wonderful week, everyone. And
catch you in our Discord server.
Catch you later on the Discord. All right.
Good night, everybody.
Good night. Bye.
Good night.